What you see on the screen right now is a reminder that this advisor webcast is intended for informational purposes only. Any features or functionality described for Oracle's products remains at the sole discretion of Oracle. Next slide, please. Amita, if you're ready, I'll turn the webcast over to you and you may begin.
Thank you, Pushpa. Yes, I'm ready. Hello, everyone. This is Amita from Database Security GCS team. Thank you, everybody, for joining today's webcast. Today, our topic of the webinar session is Understanding TCP/TCPS Packet Exchange in Oracle Database using Wireshark tool. So what are the topics being discussed in this webcast is overview of OSI reference model and Oracle NetStack communication. How do remote clients connect to Oracle database? Demonstrating the NSP packet exchange in SQL net traces. Introduction to SSL and its handshakes. Introduction to TCP dump and Wireshark and steps to capture the same. Analysis of successful TCP connection with Wireshark, a demonstration would be given on the same. Analysis of successful TCPS connection in Wireshark and the demo for the same. And also I would have one demonstration of having a failure UTL HTTP connection, which would be demonstrated in Wireshark when our wallet is having the incorrect certificate. And also the last one which we would discuss is SNI, that is server name indication. How do you view SNI information in Wireshark? So today, before analyzing all this packet in our Wireshark tool, it would be good we get some information about the Oracle NetStack communication, how packets are communicating between the client and Oracle database, and what is the protocol which is being used by the Oracle to communicate between the Oracle client and Oracle database. Moving on to the next slide. What is OSI model? OSI model is nothing but Open System Interconnected Model is a conceptual framework which describes the function of a networking system. It is used for the transfer of data over a network which moves through the different layers. So how does the OSI model look like? So this is how the OSI model looks like, which has been represented by a 7 layers, which goes from the physical layer to the application layer. So let me go through what each layer does in brief. So in physical layer, the information is represented in bits. So at the physical layer, it's transmission and reception of the binary bit stream over the physical medium and encoding and decoding at the bit level. So at the physical layer is how you are being connected to the respective LAN network by using your RJ cable, and how the information is being kept over the cable is through a binary. So through my physical layer, it understands the information in zeros and ones, which is in binary. Moving to the layer above the physical is the data link layer. So the information at the data link layer is being represented as frames. So what does the data link layer do? It's a reliable node-to-node transmission of frames, and it represents the physical addressing. So at the data link layer, we would have come across the MAC address. MAC address represents the physical address of any device over the network. Maybe your laptop, maybe your Cisco routers, maybe your database server. Every NIC card represents a physical address, and the physical address is nothing but the MAC address. And the information at this layer is called as frames. So the next layer above the data link layer is the network layer. In network layer, we have the information, and the information which we talk at the network layer is called the packet. At the network layer, what happens? The IP addressing gets introduced. So every device is being given the IP address, and the IP address is called the logical address. The network layer, what does it do? It determines the path so that from the client to the destination, or from the source to the destination, the packet is being transferred in a best route format. So at the network layer, it determines the path The logical addressing is nothing but your IP address. The routing is being done where they write some routing protocol so that the best route is being over there kept so that your packet reaches the destination. Moving on to the next layer, which is the transport layer. Here the information is being represented as segments. In this layer, there are two protocols that gets introduced. One is TCP protocol, one is UDP protocol. What does the TCP protocol represent? It's connection-oriented, reliable protocol. What does UDP protocol represent? It's the connectionless oriented. So for every data which you are being sent, you need an acknowledgement of that data. So Oracle Net Communication also works on the TCP level of acknowledgement. So you should know that my data is sent and I've not got any information for the data sent. So there would be a respective acknowledgement or it's not being acknowledged. So it's the most reliable way of transmitting the data. So the TCP protocol comes into the picture in the transport layer. So what does the transport layer do? It does reliable end-to-end communication where the information is represented as segments, which does the flow control, acknowledgement, and multiplexing. So above the transport layer, your session layer comes into the picture, which establish, maintain, and graceful shut down the session. Above the session layer, that's presentation layer, how exactly your data is being presented, whether it's encrypted, decrypted, or compression layer. And the final layer is the application layer. At this layer, what we get is the whole information, how the information is being accessed to the user. So your browser can be an application layer software where the respective information of the query, what you're asking from a database, from any remote server, which is being presented to you, and the browser also acts like an application layer software over here. So the information from session to application layer is being called as data. So other than that, when we have a SSL sits on top of transport layer. It's between the session layer and presentation layer together represents the TLS layer, that SSL/TLS layer. So knowing the OSI model, how does Oracle Net Communication Stack integrates with the existing OSI model? So that would be my next slide. Oracle Net Stack Communication. A database server is the Oracle software managing the database, and the client is an application that requests information from a server. The way the client and server communicate is known as client-server stack. Oracle Net software consisting of Oracle Net Foundation layer and Oracle Protocol support, which fits into the session layer of the OSI model. TNS technology. Oracle client and server use TNS as their data exchange protocol. TNS is the proprietary protocol for communication with Oracle database server. So how does Oracle Net layer integrates with the existing OSI model? As we say over here, Oracle protocol support fits into the session layer. So we know where exactly the session layer was from the previous slide. It was right above the transport layer. So over there, my Oracle Net layer sits. In that, we have two integration. One is Oracle Net Foundation layer and Oracle Protocol support. So to understand how a Oracle client and Oracle database is communicating, there should be a language. So the language is the protocol. So what is the protocol? They both exchange, and the information being exchanged with what protocol is nothing but the TNS protocol. So any information between my Oracle client and Oracle database, the language, the protocol, what it understands is through a protocol, which is our Oracle database server protocol, which is being introduced, integrating with the OSI model, and that protocol is called a TNS protocol. In coming slide, we'll get more information how exactly the packet exchange takes place between an Oracle client and Oracle database. Okay, how do remote client connect to Oracle database? Okay, first the remote client to connect to the Oracle database, it would pass a client SQLnet.ora. It would say like I would go as an easy connect method, TNS names method, or a LDAP server. So what information a client needs to connect to our Oracle database. So we would say it as a connection string also. So it needs a protocol. It needs to know the database host which is connecting. It needs to know the port number where that particular host is being served. And it needs to know the service name of the instance which it is connecting to. So this is a brief step how exactly the TNS packet communication happens. Client sends a TNS connect packet to the appropriate listener. The listener responds with TNS resend or redirect packet. So every packet has a prefix called NSP packets. In coming slide, I would get more information on what exactly the NSP packets are. And after the listener responds with the resend packet or a redirect packet, client responds accordingly. A final connect to a database server sending a second connect packet. Server either responds with an accept packet or a refuse packet. So moving to the next slide. How does the connection string look like? I have an example over here. So my connection string, as I said, I need a host, the IP address where I need to go and connect being a client. So over there, on which port number I need to go and connect, what is the service name I need to go and connect, and what is the protocol I need to go and connect. So the ORCL and SSL can also be known as TNS alias name. Instead of pasting SQL plus and that whole connection string to connect, we can just use the alias name SQL plus @ORCL. Provide your credentials to connect to the database. You would get connected to the database accordingly. So this is how the connection string information looks like. So transmission control protocol. As I discussed from my first slide of OSI model, transmission TCP protocol is the protocol which gets introduced in the transport layer. So you have a reliable packets being received at the database server. So over there, whatever packet has been sent, you have an acknowledgement of that packet, whether the server is being received it or it didn't receive it. That's the reason TCP is called as connection oriented, the most reliable form of protocol. So it provides a secure and reliable connection between two devices using a three-way handshaking. TCP uses the full duplex connection to synchronize and acknowledge client and server communication. There are three steps the way three-way handshaking is done, that is sync, syncACK, and ACK. And this is the first handshake which happens with Oracle database. So over here, I have a pictorial representation when a client connects to the database server. Every client picks up the port number, and that port number is called as the ephemeral port number. It can be any port number, a random port number. So it picks up the port number, it sends a sync packet to the database server. So who is hosting this service for me to connect to the database? It's nothing but the listener. So the listener is the one which is hosting the service to connect to the database, and the listener would run on its respective port, maybe a default port, or you would have a customized port to get connected to the database server. So you have a port being picked at the client, a random port, and at the listener is running and the service is available. So the client sends a sync packet. If everything is good, there's no network issue in between, there's no firewall or a load balancer blocking the respective port of communication going to the database server, the database would reply with syncACK packet. So for that syncACK packet, the client would respond with acknowledge packet. So over here, what you need to know is this is just the first handshaking happens to make sure the port is opened at the database server level and there is no any network issue between the client and the server. The route is clear. I'm able to connect to the database and the database sends the syncACK. For that syncACK, I send the acknowledgement. My three-way handshaking, the first step to connect to the database is completed. So what is the role of listener? As I mentioned, at Oracle database, it is the listener which is acting as a port which is serving the connection, which takes the connection and hands over the connection to the database server. So listener is a service that runs on the database host and receives requests from Oracle client and then forwards that request to the database server. Listener services runs on port, IP, and TCP or TCPS protocol, and services are registered on the same. So when you need to configure a listener, at the listener level, it needs to know the port number, what you're configuring, the protocol, why the listener should listen on, and the IP address, and the respective service from the database gets registered on the listener. So the basic connection, how it goes is client application first connects to the listener, and the packet is called the connect packet. So listener would process that connection and say, hey client, you're good to connect now. I have your service. Now you send your second connect packet to the database to the database. From here, you would be connecting to the database. So from here, my job is over for this particular session of connection. I would serve the other connection. You're directly connected to the database instance. Now, how Oracle Listener understands this packet, that is with the prefix NSP in its packet type. As I mentioned, for a Oracle database to communicate with Oracle client, the protocol uses TNS protocol. Okay, we understood it's a TNS protocol, how they communicate with each other. And each packet what I'm sending to the Oracle database, how Oracle database understands, okay, this is the packet I'm getting. That's nothing but Oracle has introduced a packet with a prefix called NSP packet. With this prefix of the packet, I get to know a Oracle database or a client get to know what kind of packet it is. Okay, so each packet has a keyword that denotes the packet type. All packet type begins with the prefix NSP, where NSP, TNCN used as a connect packet. AC means it's accept packet. RF is refuse packet. RS is resend packet. DA is data packet. CNL is control packet. And MK is marker type packet. Okay, now coming to a successful connection flow. A client with the connection string information, it wants to go and connect to a database server. So connection string information, we know what all information it has. So the first packet, what the client sends with the connection string information is called as connect packet, which is NSP TCN. This is how my Oracle database understands, okay, it's a connect packet, means it has a connection string information. So for every connect packet, if that listener is running on that respective port number, it would say, hey, I got your connection, the service is available. You need to resend this packet. So the troubleshooting lies between sending the connect packet and listener responding with the listener packet. So what happens is listener takes that connection, it forks the connection and makes it into a child process and sends the resend packet. So for that resend packet, when that resend packet is received at the client end, it would send the second connect packet, and again it would have a connection string information, and the second connect packet goes to the database. For this connect packet, the database should respond, hey, I accept your packet. So from over here, you're connected to the database. Let's start with the authentication. You send me your username and the password. I would authenticate whether you're good to go and get connected to my database and the session is established. What if we have in a rack setup, there's a scan and picture. Scan never takes the connection. It would redirect the connection to the VIP address. So when you connect as a connection string, you would connect with the scan host name. In the scan host name, it would be the 3 IP address. It would translate into the 3 IP address, and the scan provides the scalability and high availability. So among one of the scan you go connected, you won't be knowing which scan IP address which is connecting unless you have a traces enabled. What would scan do is, hey, I got your connection. So what you have to do is you should go again and connect to the node listener. So at the scan listener end, in the client trace, you can see a packet called as redirect packet. So the redirect packet is issued only by a scan listener, which should have the information which node listener it should go and connect. So again, it will be the same process. My client got the information. I need to connect to this particular VIP. Again, it would send the second connect packet. The node listener would send the recent packet. Again, over here, if scan-in picture, it would be a third connect packet which would go and get connected to the database. For that packet of third connect packet, database would send the accept packet, and after the accept packet, there would be a authentication happening and the client would be led to connect to the database. Okay, so connection, everything is done. You connect as a session is established, you're connected to the database. So you have certain SQL queries, you execute the SQL queries. So you need to gracefully exit the connection. So you say exit from your session on the database server. So the graceful closure of connection on the OSI model is being represented as finished. A client sends finished. So for that, a server responds with the acknowledge packet. Again, the server says, I'm also finished, and the client responds with the acknowledge packet. Okay, now this is the place I would demonstrate. Okay, we have seen all this NSP packets you're talking about. How do we see when we are troubleshooting the NSP packet? So sometimes Oracle says a client is not able to communicate with the Oracle database. You get some error. So what we say, please give us a client trace and the server trace, the listener trace. So how does a client trace? So we say enable this level 16 trace. So how does the trace looks like at the client end? So it's the same trace at the server end. The client is being replaced with the server as a word, and you have a listener trace also accordingly. So in the trace, what we say is there is some communication which you're not able to connect to the database. So Oracle support says give us client trace, give us server trace, and sometimes they would ask you the listener trace also. So what you have to do is you enable these traces and you reproduce this error and you send it to the Oracle support team. Okay. What do you see in this traces? So over here, I would explain a successful TCP protocol connection. What are the information you see in this connection? As I said, when a client connects to the database, it goes with the connection string. So the first connection string, what it goes, and the packet is being represented with the prefix called as NSPTCN. That's the connect packet information. And for that connect packet, the listener should send a recent packet. And in the client trace, you would see that packet as got recent packet. So next connect packet, what you would see is the second connect packet, which you would directly connecting to the database. So let me demonstrate how the trace looks like. So going as a TCP connection. So this is what we do is we enable that SQLnet traces from the client end and the server end. Here, I would just demonstrate the client end traces, how it looks like. So it can give you an overview when you're troubleshooting why exactly my network connection to the database is failing. So if you have a client connection, so the first step, what you need to check is your client connection would go and your TNS connection string would get translated with what is the protocol you need to connect, and if you're given a host name, that would get translated into respective IP address, the port number. Okay. After that, you would see the host IP address, it gets recorded in the client trace. Always have a level 16 traces. After it is being recorded, which I mentioned, the first handshake which happens at the database level to connect to the Oracle database is the three-way handshaking. So over here, you can see opening the transport. So after opening the transport, you see you're connected on a source IP address, port number, this random port number. This is the port number which I talk about, the ephemeral port number. The client picks up this port number. So the database is running on a listener port number, but what is the port number which the client picks up? By having client trace, you can get to know what is the ephemeral port number for that session the client trace picks up. So after the transport is open, you can check the client has picked up the port number and this is the IP address the client is connected on and the transport is open. So if any error after making a client trace, if you see an error between this and this saying the transport is being closed, instead of opening the transport, if you see the transport is closed, That indicates there is a network issue. B, there is no port being open from your network to connect to the Oracle database, or maybe Oracle listener itself is down, which is not serving the connection. So you can approach the problem by having the client trace your first set of handshake works or not. Good. I'm done with my three-way handshake. It's successful. So what is the next information we go? Hey, I'm going with the connection string where I say I'm going with this protocol, this IP address, this service name, and this is the database I want to connect to. So what is the connection string information? What we go as? Okay, as I said, for my database to understand the packets which is going, it understands with only NSP as a prefix and what kind of a packet it is. So from the client trace, you can see over here, sending the NSPTCN connect packet. So what is the information in the connect packet it has? It has the information of the connection string, which it needs to connect. So when the connect packet comes, it reaches. When you see this connect packet has gone, we think it's reached because transport layer, we see the port is open, there's no error over there, three-way handshaking is successful. Next is a listener level connect packet comes. So what should listener send? As we discussed, it should send a recent packet. So if you're not getting this packet in the client trace as NSPTRS packet, which is a recent packet, so there is some issue at the listener level. You're sent a connect packet. If you don't see the recent packet, you need to check your listener log or have a listener trace to check why exactly I'm not getting a recent packet from the listener. So to get a recent packet, it goes from a packet coming to the listener. What listener does is it takes that connection, it makes sure that service name is available on the listener, and it would fork the connection. So the process of forking a connection from the parent process to the child process and handing over that connection to the child process, that process can be a problem sometimes. So when can it be a problem while listener is not sending a recent packet? Maybe listener has reached a threshold. There are too many client connection which is coming to the listener and it's not able to serve the connection. That's the reason it's not able to spawn the process and send the recent packet. So number of factors at the OS level also for listener not working properly uh, can make a listener not to send a recent packet. So your way of troubleshooting should be, for my connect packet, did I get a recent packet? Okay, the recent packet has done. If I'm not got it, let me check my listener log. Let me have a listener trace and check like why exactly I'm not getting a recent packet. So I got the recent packet, a successful connection trace, what we are having the demo over here. Good, I'm connected to the listener. So what did I say? The next packet is sending the second connect packet. The second connect packet goes and gets connected directly to the database server. So again, what does the connect packet information contain? It contains the information of the connection string. So when we connect, so the second connect packet goes directly to the database information. So for that second connect packet from the database, you need to get a packet called as accept packet. So you can see over here, accept packet has come over here. So database says, hey, you're good. Come, let's have authentication of username and password and let's get connected. So after having an accept packet, always Oracle Net team would say, hey, what is the connection ID? This is the place where connection ID gets created. From the source, from the client trace, a connection ID gets created, and the same connection ID would get created as the server level trace also. This is the connection ID which matches between the client and the server. So when Oracle support team says, hey, give me the matching connection ID from the server also, you need to pick the connection ID from here. You would have a lot of server trace. Grab this connection ID from that server trace. You would get one file which is matching this connection ID and give that server trace to the Oracle support. So the connection ID gets generated at the server level only if there is an accept packet, which has come from the database. And after that accept packet is being generated, now there is a session connected between a client and the server, and you get a connection ID for that. So after the connection ID is being done, So this is the last process which happens with the database level, where we send NSPTDA, means it's a data packet which is going from the client to the server. So there is a data packet which goes, and after the data packet, it's all about the authentication, where my username. Also from here, you would send the information. SD means send. RC is receive. So it depends on what trace you're seeing. In client trace, if you see SD, it is sending the packet. So if you see a keyword called RC, it means it's receiving the packet. So here client says, hey, from my example, my machine was a Linux machine, so it sends the information of my operating system. And also from the database and the client trace receives the operating system information. Even this is a Linux box. So after that, okay, we exchange over here. We got to know we both are working on a operating system level. So even that information would be recorded in my client traces. Then the authentication packet happens. So I send my username over here and I send my password. For sending packet, you would get a receive from the database server saying that the respective username and the password what you have sent. I'm just authenticated, and there's some process of authentication based, whether it can be a password file authentication, a Kerberos file authentication, or a SSL file, SSL based authentication. All this happens at the database server level. And if you have a client trace, you can check between what is being sent and what is being received. So all this authentication happens. So the finally, how we check is you're being connected to the database or not. The final packet, what you check is after authentication, you would see, we call this as the final banner, which you receive in the client trace. It is nothing but my Oracle database information. My testing over here, I did it on a 19C database. So you can see a final banner with Oracle database information if you get it. If you get this packet in a client trace, if you see this packet in your client trace, you can be sure that you are being connected to the database. And after that, your session gets established and you can do a respective query, what you're supposed to do, and you can exit the connection. So why exactly I am mentioning about this is based on this, if you're aware about what are the kind of packets which is going as a connection flow, you can do the troubleshooting based on that. Okay, did the first three-way handshaking happen? Okay, the next is, did my connect packet go? And for that connect packet, did the recent packet come? And did my second connect packet go? For that connect packet, did I get acknowledgement packet? Okay. After that, did the session get established with the connection ID? And after that, all we see is, did I get a final banner or not with the authentication? After authentication, did my final banner come from the database? Okay, I got it. So my session is connected to the database. So we are good. This is the way how we check at the Oracle support and also and encourage even customer when you're coming to see like where exactly at what level having the client trace and the server trace and even the listener trace, you can make out like why exactly we are not having certain packets and at what level we are failing. Okay, now coming back to the slide.
Hi, Amita.
Hi,
We
Pushpa.
have some feedback to slow down your pace of presenting if possible.
Okay, sure. Thank you.
Thank you.
Okay. Now, coming to SSL and SSL handshakes. Okay. The main purpose of an SSL is to provide a privacy and data integrity for communication between a server and a client. During the handshake, server and client will exchange important information required to establish a secure connection. Why an SSL certificate? We need SSL certificate to keep a user data secure, verify ownership of the website server, prevent attackers from creating a fake version of the site server, and convey trust to users. Okay. So what we are saying is in SSL handshake, what is the purpose we are using a SSL over here? SSL/TLS. It's to provide a privacy and data integrity for communication between a server and a client. So how does a SSL work? It would work with the concept of certificate. So we need a SSL certificate to keep user data secure, verify ownership of the website server, and prevent attackers from creating a fake version of the site. There shouldn't be any attacker who would just create the same certificate and come and get connected to us. So that's how the user gets a trust and gets connected to the respective destination. So how does a SSL handshake work? So as we say, three-way handshake at the TCP level, there is something called as a SSL handshake also. So how does the SSL handshake work? So these are the packets where the SSL handshake works, that is client hello packet. So what does the client hello packet goes like? The client hello packet message sends a message to the server. So it's a client hello packet. So what does the message include is, it includes a list of algorithms supported by the client, the list of ciphers, and the TLS version. So when we are I'm coming and getting connected to the destination with the SSL as a protocol with the SSL certificate. First packet of handshake, what it goes is hello packet from the client end. And the information what it has is, it has a list of algorithms, the list of cipher, and what is the TLS version. So for the client hello packet, the server should respond, right? The server responds by sending a hello message to the client, and this message includes, hey, you sent me this list of algorithm, this version, and this list of cipher. In this, I'll choose one cipher, I'll choose the version, and I'll choose the algorithm. Also, I'll send the certificate which is there at my end. So that would be the information from the client hello. There will be server hello with the certificate and server hello done. So for the server says, hey, it is picked up, it is sent a server hello also, and the server has presented the certificate. Okay, this is the server is saying this is the certificate it has. So the client is like, okay, are you a right server with the right server coming and asking me the connection? So the client authenticates its server certificate. So client would see from its key store, this is a certificate what client is saying. Do I have this certificate in my key store? Oh yes, I have this certificate. Not only you need to have that certificate, the public key of the server certificate should match what is there in my key store. So after matching, okay, the certificate, I have it in my store and the public key is also matching. Good, you're the right server for me to connect. So the client generates a random value pre-master secret key and encrypts is using server public key and sends it to the server. And the server uses its private key to decrypt the message to retrieve the pre-master key. If the server doesn't have a right private key, it would not be able to decrypt the message what the client has sent. So over here, again, checking the information, the client hello packet, it would send the supported version and the cipher, and the server would send the chosen cipher, chosen version, and also the certificate, and also a message called as server hello done, and the client would check all the information whether the certificate is correct. Do I have the same certificate what server is sending in my key store? Okay, right. It's the same public key. I would send a client key exchange, and also from here, these keys are not sent to each other because the keys are calculated based on pre-master key and the randoms which are known to each other. The encryption keys and symmetric, that is same key is used to encrypt and decrypt the data. So when everything is good, those certificates are matching what is there in my key store. The client and server sends a fine finished message to each other. These are the first message that are sent using the key generated in the previous step. The finished message includes all the previous handshake message that each client sent. Each side verified that the previous message that is received match the message included in the finished message. This checks that the handshake message were not tampered with. So finally, the client and server now transfer the data using the encryption and hashing key algorithm. Let me get back to the client. This slide, the client hello packet, server hello, certificate the server hello sent and the server hello done. So for that, the client sends a client key exchange. So over here, I've represent one-way handshake. If you're using a two-way method of handshaking, the server would ask client certificate also. Hey client, you're a right client for me to connect. Just provide me your certificate. So the packet would go as requested client certificate. So the client would send a certificate. The server would check, who is this the right client certificate which I have in my wallet? Okay, we are good. So over there, you have a two-way method of authentication of the certificate where the client would also authenticate the right certificate with the server end. So if there is a two-way, both the way the certificates are authenticated, then a pre-master secret goes, then the final message goes as this is the final cipher specification I'm going, and the respective client would send client finish, which is the encrypted data. For the same thing, it would decrypt the message with its private key and send the chain cipher specification and also server finish. So these are the handshake from 1 to 9 which happens. After this handshake, there would be the information called as application data, which would all be encrypted. So other than that, I would like to give one more information. Hey, you're talking about cipher suits, right? What does the cipher suit information contain? So what does the cipher suit information contains it? It would look something like this, the way I presented over here. TLS, DHA, RSA with AES 256, CBC, SHA 2. So the first one talks about the encryption protocol. This represents the key exchange algorithm. This represents the signature algorithm. This whole chunk represents the bulk encryption algorithm, what it is using. And the last one talks about the MAC algorithm. So when the client sends a list of ciphers to connect, server would pick one of the cipher what the client has sent it. So the cipher information contains this information, the key algorithm, the bulk information algorithm, and the message code information algorithm. So now we know, okay, why exactly we need to have a secure communication and nobody should tamper my data when the data is going from the client and server. Okay, at Oracle database level, how exactly the handshake happens? So the handshake is the same SSL handshake which is happening at Oracle database level. But who is storing the certificate? So Oracle database, the key store which holds the certificate, we have the term called wallet, which we are aware about. So the wallet has the information which holds my certificate at the client end and at the database server end. So what is the information the wallet contains? That is requested certificate, user certificate, and the trusted certificate. So when a Oracle database sends the client saying that, hey, this is my certificate, you connect to, in the client trusted certificate, it should have the respective server certificate, what the server is saying, you need to connect me. So the respective certificate of the server should be kept in the trusted store. So this is the place where client validates, hey, I have your certificate in my wallet. So which wallet, which location? That is trusted certificate location. So it says, okay, I have the same certificate, what you're saying, and I have it in my wallet and my public key is matching. So we are good to connect. So what I want to tell you at the Oracle database level, a place, a key store which holds the certificate is nothing but the wallet. Okay. Now, introduction to TCP, dump, Linux, and the Wireshark Windows and sets to capture the same. Before going to that, what I want to demonstrate is some time back, we saw how a client trace looks for a TCP-based communication. I want to demonstrate how exactly a trace looks for a TCPS connection and how you can troubleshoot the same. Okay, now I've got a client trace going and connecting to the Oracle database with a protocol called TCPS. Okay, so here, just a minute. Here, the first way what we connect is we pick up the connection string, be it a TNS name connection string or a easy connect string. It gets recorded in the trace with the information. What is the protocol we are connecting? What is the host we are connecting? What is the port number we are connecting? Okay, we see that in the client trace. So it picks up the host, that is nothing but the database host IP address. I'm demonstrating just the client trace over here. So after that, from the previous slide, what I said is the first level of handshaking, what happens is the three-way handshaking. So to make sure the port is open and we are able to connect to the Oracle database. So over here, the three-way handshaking is the same process, opening the transport, and we get to know the respective client is being connected with the source IP address and the port number, what it picks up, the ephemeral port number. And after that, now it's a TCPS connection and the transport layer is open. What is the next? So at the Oracle database, we say we have a wallet information to connect to the database. Okay. So when you're troubleshooting, the next set of information what gets recorded is the wallet information. So you have in the client trace, you would get to know which wallet location it is representing and picking up the certificate. Okay. So sometimes you might not be a wallet not open or it is picking up a wrong wallet location and you're having a problem. So by having a client trace, you can see, hey, which location it is picking? What is the wallet location it is picking? Let me check in my client trace. What is the wallet location is picking? Okay, well, sometimes we might have a problem, though the wallet location is being picked. The wallet, the files inside that might not have a permission to get read. Even if it is related to that would get recorded over here whether the respective wallet location have a permission to get read or not. So the information inside the wallet would be e-wallet P12 file and the cwallet.sso file. So from the client trace itself, you can get to know if you are troubleshooting a TCPS connection, you can get to know like what wallet it is choosing and which location it is choosing the wallet and whether it is opening the wallet or not, or do we have any error over here opening the wallet. Maybe it doesn't have a right permission for the groups to open the wallet or the user to open the wallet, and you need to check the file permission for this respective wallet. Next, three-way handshaking is done, good. And we got to know a right wallet is picked up. And now over here, what you can see is a SSL handshake can be seen. So here, after the wallet gets picked up, my listener is serving. Over here, I've taken an example as port number 1522, which is serving a TCPS connection. So what I said is first client hello packet would set a list of cipher. In my client wallet, I have added in the trust location a certificate, a self-signed certificate called as CN is equal to DB security team, which I showed in the previous slide. So for that, in the client trace, you can see this whole handshaking, how exactly the handshaking is happening. So the first one is you can see over here, a client hello packet goes. Okay, I see that in my client trace. And for that client packet, you also see a server hello packet. And after the server hello packet, you would also see coming down what is the certificate the server is presenting to the client. So between client over here, adding its certificate and you being getting the respective certificate from the server, you can troubleshoot if there is any certificated related error. So finally, all good. I have the same certificate what server is representing in my wallet. So the next would be like we pick up protocol to what we are working on. The protocol gets picked up. After that, the server sends server hello done. Client says client key exchange. There is a change cipher specification happens. And from the server end also, it would be like SSL negotiated and finished successfully. This is the final message which you have to see when the SSL is being used as a connection between a client and the server. When you get this message finally, then it indicates you're able to communicate with the database server and the certificate has matched. We won't have any issue related to the ciphers or the versions or anything to do with the certificate. Then it picks up the final, it writes a message called as SSL negotiated finished successfully. And after that, this is the final cipher. Sometimes Oracle says, hey, what is the final cipher? You would have a error related to the ciphers, or you would have a specification from your organization. This respective cipher should be used. So by over here in the client trace, also you can see what is the final negotiated ciphers which can be seen. Okay, in the client trace over there, you can see a message for the finally finished successfully. This is the final SSL handshake has been completed. Okay, now coming to the thing. Okay, you just mentioned SSL handshake is done, but I am going as a connect packet and my database should receive. Parallelly, you would see in the client trace, it would represent like the first recorded session, the first recorded traces would be the handshake. Parallelly, the connect packet information is also recorded. So here you can see the connect packet is the way you go and get connected to the database, right? With the information of the protocol, the IP address and the port number. So for the TCPS connection, also you can see in the client trace sending the NSPTCN packet. This packet would be seen right after the first handshake is being completed. However, in real, it's been happening parallelly where the connect packet is reaching the listener. Handshake is also happening, but in the trace, you can see the connect packet is being just recorded below after handshake is being completed, the SSL TLS handshake. So sending the connect packet. So after sending the connect packet, from now on, you would see everything is encrypted because they are going as a TLS protocol. So but in the client trace, you can still see this connect packet information has this information. So for the connect packet, what should listener send? It should send the recent packet. So in the same client trace, just check whether for that connect packet, you're getting a recent packet or not from the listener level. Okay, you got a recent packet from the listener level, but over here, I need to put one information in the client trace. Again, you would see a renegotiation of SSL handshake being happening, which in real, there's only one SSL handshake happening. But if you have a client trace, in the client trace, you can see again a SSL handshake gets repeated. If it is past the first level of handshake, it would get passed when it is at the listener level renegotiation also. Again, you can see the renegotiation happening at the listener level. This just gets recorded as a client purpose. So writing a hello packet for the client hello packet, you would have a server hello packet. After the server hello packet, the server would represent, hey, this is the certificate what I have. And if it is matching, you can see the finally the server sends hello done, client key exchange, change cipher specification, and we would get negotiated over here. Finally, SSL negotiation finished successfully, and you would pick up the cipher what you want to communicate. Until here, you are done. Handshake is completed. Listener says, you're good. You need to send the second connect packet. So irrespective of a TCP connection or a TCPS connection, the way my database would understand the packet is only with NSP packet, which has the information of the connect packet, listener sending the recent packet, and again the client sending the second connect packet, and the database replying with the accept packet. If there is a problem, there are chances sometimes a database can send a refuse packet also. So now My second connect packet gets connected to the database, and for that second connect packet, you would have an accept packet. This is at the database level. As I've told, after the accept packet, there is a connection ID over here to pick up the connection ID. This would be the common connection ID, which would be shared between the client and the server. And this is the same connection ID number, which would be there in the server trace also. So after this, it would be checking on an adapter. This is the protocol. That's nothing but the TCP/IP protocol, what I'm demonstrating now. That has the information from here. The authentication based on your username and the password happens, whether you're a right username to connect to the database or not. The client trace looks pretty exhaustive because it has the information of the encrypted also and also the unencrypted, because we are having the level 16 traces. So after that, the client sends what is the operating system it is using, and the server also responds, okay, that's the operating system I'm using. So finally, what I say is to make sure after the authentication packet, you receiving this packet, sending the auth packet and all, finally to say whether you've been connected to the database or not, the final information what you need to see it is whether you got a banner information, this particular RC. In the client trace, you need to see whether this banner information of the respective database is being received or not. So your troubleshooting is between the transport layer getting open till getting the banner information from the database. If this information is received in the trace, that means you're being connected to the database, your connection, the session is established, and also you can do the respective queries and gracefully exit from the connection. Okay, so this is what I wanted to show you the difference, how exactly the TCP client trace looks, how exactly the TCPS client trace looks. In the TCPS client trace, so you have information of that whole ethical handshake, and also you can get to know what is the certificate which is being kept at the client end, which is being kept at the server end, and what is the wallet location it is using to communicate. So any point you're having a wallet related error or a certificate related error, through client trace only you can get to know where exactly the error is. So here the client is adding the certificate, means the certificate at the client end, and in the server communication, this particular line, certificate verify, this would be the certificate where server is representing, hey, this is the certificate I have it from my end. Okay. So this was the difference which I wanted to show in the trace. Now, coming back to the slide. Now we would go to how exactly we can capture the packets with TCP dump and Wireshark. Now, TCP dump. What exactly is TCP dump? This tool widely used command line packet sniffer or a package analyzer tool, which is used to capture or filter TCP/IP packets that are received or transferred over a network on a specific interface. So how do we capture a TCP dump? Okay, I'll demonstrate this. So TCP dump can be used with multiple filters. So TCP dump, how do you write it? Is TCP dump -I represents the interface, -S represents define the snap length size of the capture in bytes. Use -S always as a pro tip. I'll tell you, you would enable the TCP dump for an interface. -I interface can be your respective Ethernet interface or any interface that you capture the traffic on. If you're not sure about what is the interface, you can capture the traffic on all interface by saying it as any. As a pro tip, always include -S0, using -S0 to get everything unless you're intentionally capturing less information. When a support says give me a TCP dump, you need to enable the TCP dump with the interface. You should be knowing this is the interface you would be using where the packet communicates with the outside world. If you're not sure about the interface, just make it as any, and with that the option as -S0 and -W lets you to write the output of this complete TCP dump into a file. So you enable the TCP dump, reproduce the issue. How do you stop the TCP dump? Is nothing but a simple Control C after the problem has reproduced. Also, when you're enabling the TCP dump, you need a root permission most of the time. You need a root permission to enable the TCP dump. Let me demonstrate how to enable the TCP dump. Okay, I have a Linux box over here. I log in as my root permission. So to know what is the interface available on my respective database server or respective client, you need, if it is a Linux by itself, that time you're using the TCP dump. So TCP dump with hyphen D in caps lets you know which is the interface available at your respective database or a respective client machine. In this interface, you need to know which is the interface which is used for the communication, which is the interface, communication interface, where it would talk with the outside world, which is that interface. So if you're sure about the interface, all we have to do is write that respective interface, and just if you're not sure about the interface, what you have to do is you can just say as any. It picks up all the traffic from all the interface, and I'll just say 2D and .pcap. So let me tell you this. Okay, let me tell you this. Hyphen I. After hyphen I represent the interface where you need to capture, then hyphen S0, hyphen W writes your output to that respective file. So over here, I enable the TCP dump. So one more session, what I do is, okay, I've enabled the TCP dump, and what you need to do is you need to capture those packets. You need to reproduce, so you need to get the traffic dump of this. So in another screen where you've enabled, just reproduce your issue. SQL plus over here, I would say like ORCL, which would ask my username, password. After that, the TCP dump is being captured. We got certain error. All you have to do is Control C in the same session. You would be like, okay, TCP dump is being captured. Where exactly is this file is? Do ls-l on the same path over there. You would get to know that today whatever we have captured is being sitting over here. It would be on the same root folder where the captures would be sitting. Take this capture, and if the support is asking, give this capture to the support, or if you're able to analyze with the Wireshark, which would be my next slide to demonstrate how it can be analyzed in the Wireshark, you can just take this dump, put it into the Wireshark and start analyzing it. Okay, so this is how you capture the TCP dump. Now, coming to the Wireshark. So Wireshark is the same capture tool which is used on a Windows machine. Okay, so how does a Wireshark look like? This is just the pictorial representation as a snapshot I have pasted. I will also show a demonstration of it. So this is how a Wireshark would look like. As a TCP dump also, it picks up an interface, right, to capture the traffic. Even in Wireshark, you need to pick the interface where you need to capture the traffic. So you pick the interface over here and the captures would start. Then, keeping Wireshark ready with the necessary tabs, that demonstration which we'll do. View tab, column preference tab. The pro tip, I will tell you what is the basic as pro tip, important tab which is being required instead of having many tabs in the Wireshark. Okay, then after that, how do we sort? You'll be like, okay, I have dump of data which is being captured in the TCP dump. I'm putting that dump of data into the Wireshark. How do I sort this packet? So the step one would be filter the packet based on IP or port number. Click on one packet and do a follow TCP string. Sort it in an order that would be by serial number to get the right sequence of packets. Okay, just have a look at it. We will also have a hands-on demonstration of that. So the first step, what you do is you filter in a dump of file, you filter the packets And after filtering the packets, what you do is you click on one packet, say follow TCP stream. After that, you sort your packets based on serial number. Okay, let me open the Wireshark for today. So you have a Wireshark, which has been open source software. You download it, done. If your database or your Oracle client is a Windows machine and support comes and says, hey, give us a Wireshark output. So if there's any network communication kind of a error, let's check what exactly the Wireshark is capturing. So all you have to do is when you open, you need to pick an interface. Over here, my interface is Ethernet interface. Double click on this. All the traffic over here gets captured. After you reproduce the issue in one more secretless as a command prompt in the client, okay, the packet capture issue is being reproduced. Packet is being captured. How do you stop your Wireshark? Is a red button over here. Stop. This stops the Wireshark, and over here you say as save as a file. By default, it would pick up the file extension. So you can just save it as today too and save that file. Okay. So other than this, as a pro tip, I'll tell you what are the important to start off analyzing the packets in Wireshark. What are the important fields you needed? So the first field what you would be needing to analyze the packet is just make sure you have main toolbar, filter toolbar, status bar, packet list, packet details, and packet bytes. All this being check mark. Okay, I'm ready with my view bar. View. The next is you can see over here, these are the column preference which I have included. So these column preference are enough for us to analyze the packet. So the column preference over here is what I do is column preference. So what are the columns I've included is one is the serial number, one more is the time format, one is the source address, one is the destination address, one is the protocol, the packet length, the delta time, and the description. If you have like you need some more information over here, you can have your own column with extra. If you need a port information, you can pick a port information over here, and like you need a destination port as a column also, and name it as destination port. But as a pro tip, I would tell you this information is enough for you when you start analyzing your packets in Wireshark. That is having a serial number, having a time, having a source IP address, destination IP address, the protocol, the length of the packet, the delta, and the description. In the description itself, we can get to know the port number. So you need not have to have one more extra column over here as a port number of source and destination also. So having this packet, having this column preference is more than enough for us to analyze the packet. So we got to know from the view what are the important tabs we need to have, and from the column preference, this is called the column preference, what are the important fields. As a pro tip which I gave you, this column preference would be more than enough for us to analyze the packet. Okay, this is done. So we got to know in TCP dump and in Wireshark, how do you capture the packet? It's via the interface. How do you stop your trace after you capture the issue which is being reproduced? In TCP dump, it would be Control C, and in Wireshark, we would go as a stop button, and we would after going as a stop button, we would save the file, and you would get that file respectively. And in TCP dump, you should always use that if you're analyzing this file in Wireshark, you need to always capture this file and put it into a format of .pcat format. Now, after this, my next demo is analysis of successful TCP connection with Wireshark. Okay, now we spoke about how exactly the client trace looks for a TCP connection. Now, what I did is I made a successful TCP connection from the client to the server Backend, I enable the TCP dump because mine was a Linux box. As client also, at the server also, I reproduce the successful TCP connection and I enable the TCP dump and I capture the traffic. So this is the successful TCP connection packet which got captured. Let me open it in my Wireshark. Double click on this if the Wireshark is being done. So you would be like, hey, so much of information over here. How could I sort my packet? So the first step is if you're sure about which database you're connecting to, you can sort your packet based on the port number, and the port number for my TCP connection was the 1521 port number. If you're sure about the IP address, what you need to connect to, I mean, IP address of a source or a destination, you can sort your packets based on the IP address also. So it can be based on the IP address or the port number. So I would pick, I made a successful TCP connection. I know my destination was 1521 port number. So I put this filter in this dump of trace. I put this filter. You can put the filter based on IP address or the port number. And you can see a right arrow key over here. Just say as go. Okay, I got the packets for that respective port number. But I need to know there will be so many connections, right? So you need to know like which exact connection, if you are having the client trace, pick that respective ephemeral port number. That is that ephemeral port number. Take one connection over here. Say this is step number 2. Follow TCP stream. After following a TCP stream, you get only the packet which is for that respective session connection. So you get the packets all sorted. One is you sorted based on port number, then you sorted based on the client ephemeral port number so that you're interested in that packet communication. Done. 2 steps is done. Next is you need to sort. That's the third main. Sort this packet. So you go to serial number and sort the packet. Now you have your packet information over here, which goes as per the ascending order itself. So as we discussed previously on all things, now you can see the same information in Wireshark. So the first level of handshake which is happening is nothing but the 3-way handshaking, where the client goes with sync packet, the server replies with syncAC packet, and the client responds with acknowledge packet. Okay, after the transport layer being open, what is the next set of communication which goes is, it's nothing but your connect packet. You can see over here, the protocol, what we discussed in our previous slide is nothing but my Oracle database understands the packet as a TNS protocol. So you can see over here as a TNS protocol, always when you open a packet, below you would get one more window which gets open. So frame is the packet which talks about the data link layer. Here something called as Linux cook capture. You can see that talks about my place where the client, if it's a client IP address, it talks about the device of that particular client. It gives the physical name of that device. And internet protocol talks about the source IP address and the destination IP address. Transmission control protocol talks about the source protocol, destination protocol, and the sequence, the acknowledgement, and the length. You can go deep into it, like you can just expand this below packets and you can get more information what exactly in this. And other than that, what I told, the information goes as a TNS as a protocol. That's how my client and database communicate. So you can see with TNS as a protocol, the connect information is going with the connect string, and when the connect packet goes, the acknowledgement comes to get this recent packet from listener. And again, when you get a recent, since our communication is a TCP communication, which is a connection oriented, for every packet which you have got or not got, you need to have a respective acknowledgement of the same over a TCP protocol. So again, the listener sends the recent packet, which you can, what we saw in a client trace, you can see the same thing on a Wireshark. And the second connect packet goes over here. Again, the packet information is going as a TNS as a protocol. And for that connect packet, database responds with the accept packet. After that, again, it goes as TNS as a protocol. Then after that, all the information of a data packet which is going from the client to the database would go TNS as a protocol. And in between, you might say, hey, I see TCP as a packet. That's nothing but the acknowledgement which is going for your respective TNS information, which is there in the packet. Also, I need to inform you, when we do this follow TCP stream on one particular packet, there's one window which gets opened. After that window gets open, just do a hexa dump over here. When you do a hexa dump over here, this particular representation of that particular session connection would exactly look like the way we saw in the client trace, where if you click, the red packet represents the client packet and the blue packet represents the server packet. So by clicking on this, you can get to know where exactly this client connection string packet is going, how exactly, what exactly. If you click on this packet, you can get to know, oh, this is a connect packet. So again, over here, if you click on this packet, you can get to know this is the request data, this is the authentication packet which is going. So this can be handy when you're having a client trace and you're not able to get more information from the client trace. By having a Wireshark of that respective trace, you can know at what level either we have successfully been connected or at what level we have failed. So when you're working on a Wireshark, taking a dump to the Wireshark, make sure these are the mandatory fields. These are the, like, as a pro tip, I'll tell you, these are the fields which is being required. Other than that, you need to take one packet. You need to be sure, like, which is your packet over here. Follow the TCP stream. And after that, sort your packet based on the serial number. So you would get the exact sequence of that. So this is how I demonstrated the successful TCP connection. Now, coming to the TCPS trace. So you saw how a TCP connection looks like on a Wireshark. In TCPS, how does it look like? Let me open a Wireshark output for a TCPS stream. So I'm having a dump of trace. I know my TCPS connection was on a port number 1522. So I would use this easy method to sort my packets. So filter, I used it over here, say as go. After saying as go over here, I get a set of packets. So I would know, like, if there's no many connection, there's only one 1522 connection, click on one packet, say as follow TCP stream, you would get information of that particular session connection sorted based on the serial number. So you have the complete connection flow, what we are interested to see. So it's the same scenario where you can see the first handshake happens. You need to see this packet gets represented of TCP handshake, which has been happening. But in TCPS connection, you can see the TNS protocol is not being represented at all. So because right now everything gets encrypted, though in a client trace, all your information is going with TNS protocol NSP packet, but in Wireshark, you would see that information getting encrypted and going as TLS protocol itself. So right now it's the TCPS/TLS SSL connection. All the information you would see over there, the protocol represents that information of the handshake is TLS version, respective version, how the information is going. So after the handshake, you would see a client hello packet going over here. So after this, when the client hello packet goes, there is a new layer which gets introduced. Before slide, we just saw it was being ending with transmission control TCP layer. When TLS gets introduced, then the packet is going as a SSL communication. In the Wireshark, a new layer gets introduced that is nothing but transport layer security. In transport layer security, it's the place where you get all information, where the client hello message. So all the while we talked about, okay, it's picking up a IP version. In this client hello message only, you can see what's the version it's been picked up, what's the signature algorithm it is using, and also what is the cipher it is being using. So what I mentioned is for that client hello packet, server would respond saying that through your algorithm, I would send my certificate, I would pick a one cipher and I would pick one TLS protocol, TLS protocol version. So in the server hello packet, you could see what is the cipher it is being picked up. And also there is a column called as handshake protocol certificate. In this certificate, you can see what is the certificate which is coming from the database server. And if it is a database server, you can see in the server hello packet what is the certificate it is coming. So the server hello packet, you need to just go to the last transport layer security, and in that transport layer security you would get to know what is the certificate which is being represented from the client server end. So here we get to know there is a certificate in my test case called BB security team certificate. So the server hello packet certificate, what client server is saying, server key exchange. So that packet you can see it in the certificate column. So after that, the same thing, how we discuss the client hello packet exchange, client key exchange, chain cipher specification, and encrypted handshake, and chain cipher specification encrypted. This goes from the client end. Even the server should say change cipher specification encrypted handshake messages. All this handshakes would be done. After that, all your data flows as a encrypted as a application data. So also I want to show you before, if we do a follow TCP stream, there is a window which comes up. In that window, if I make a hexa dump, the previous TCP handshake, we were able to read all the information, but you can see over here, everything is encrypted. We can't read any information. This information doesn't even make sense to us because we are going as a TLS and the messages are encrypted. So this is the difference how the packet looks like for a TCP and the packet looks like for the TCPS connection. Okay. Now, after demonstrating TCP and TCPS connection, I want to demonstrate over here a failure UTL HTTP connection in a Wireshark where we are having an incorrect certificate in my Oracle database. Okay. So which is the place which holds the certificate? It's nothing but the wallet. And which place in the wallet where the authentication of the certificate happens? It's the trusted certificate location. So demonstration of the failure. What I did is I tried reaching this particular website, that is my Oracle, www.oracle.com. Okay, so I'm trying to demonstrate. I'm trying to reach oracle.com as a UTL HTTP connection. In my wallet, I'll have an incorrect certificate, though the oracle.com has a different wallet, a different certificate. In my wallet, in the previous slide, just see over here, I'm having a certificate called as Global Sign Root CA. Okay, and here I'm trying to reach oracle.com. In my wallet, I have a certificate called Global Sign Root, and I try calling that respective destination URL. When I call that respective destination URL, I have an incorrect certificate. That's the reason I would get an error as 29024 certification validation failure. I'll just show you. If I go over here, if I open, if I check on the connection is secure, certificate is valid, you can check in the certification path. There is something called as DigiCert, there's something called as DigiCert root. But for the demonstration, I just informed in my wallet, I'm having an incorrect certificate, that is global root sign. After having an incorrect certificate in my wallet, what I did is I enabled the TCP dump. I reproduced this error. Let's see how exactly the TCP dump captured. So I open that UTL PCAP machine. So the first thing what I do is if I'm not sure about over here, I would not be sure about the packet. I sort based on the protocol number. And here, after sorting based on the protocol number, I would pick up a certificate TLS protocol here, follow TCP string. After that, I would sort based on the serial number. Now you could see it's the same handshake which happened. client hello and the server hello packet. So from the server, the respective www.oracle.com, the certificate what that respective website is showing. I'll just here you can see. Yeah. So the server is coming up saying that this is a certificate in my wallet, the GCert TLS RSA SHA 256. But in my wallet, just to demonstrate so that it can be easy while troubleshooting. Now in my client wallet, I've stored an incorrect certificate. When it comes from my server end, it is pointing out to the correct information of the certificate what my server holds. It checks in my wallet, in my database client wallet. Oh, this certificate is not there. The certificate is not matching. That's the reason you had that ORA 29024 error. And also in Wireshark, you can get a alert saying as unknown CA. So the CA, the certificate authority, what is there in wallet is not matching with what server is sending as a certificate. So this way, by knowing the handshake, what server packet is coming with the certificate, it would be easy for us to troubleshoot why exactly we are having the certificate related error. Just go to the certificate packet and see what is the certificate it is representing. If that certificate is not there in my wallet, maybe there is a mismatch. That's the reason we are having that kind of error. So this way, Wireshark representation can help us in troubleshooting anything to do with the SSL TLS handshake issue and also the certificated related issue. And other than that, other than having the Wireshark handshake, there's also for a UTL HTTP connection, you can also enable at the database end 10937 traces, where you would enable this respective traces, you reproduce their error and you stop the trace. That trace also you can get to know the information, how exactly the packet exchange is happening and where are we failing. Okay, so the next information is SNI server name indication in Wireshark. The SNI means the server name indication allows the server to safely host multiple TLS certificates for multiple sites, all under a single IP address. What SNI does is it adds the host name of the server website in the TLS handshake as an extension in the client hello message. Okay. Coming to the Oracle database, there are times when you're on an 11G database or on a 12.1 database, we say reaching a UTL HTTP connection, you get an error ORA 29024. We check, hey, just if your database server, if your destination server is the SNI enabled, so that means your one single web server can host many sites. It can host many sites for the same IP address like example.net, example.org, example.com. So maybe in 11G and 12.1, we don't have that information of SNI which can go in your client hello packet. So that's the reason when you go as a UTL HTTP connection, the server is being hosting many sites. So one of the site would send some client some certificate information which is not matching to the information of the certificate which your server is holding, which your client is holding. That's the reason you get the certification related error. So this is being solved in 12.2 version with a patch. In 18C database, they fixed it permanently where you don't need any patch to have a SNI information. So I want to demonstrate over here. It's the same packet which we saw how a SNI packet looks like. So it's the same UTL packet. Here I would take my packet, follow TCP stream. Here in the client hello packet, what we say is client hello packet is the place where the SNI information goes, this is the place, which is called as server name. And in the server name, you can see over here, server name indication extension. Here you can see in the header, what exactly the information which is going as a server name. So a same website can host multiple sites. So in our header, we are just going to www.oracle.com, and this can be seen in a field called server name indication. Okay, so this talks about the SNI information which goes in the client hello packet. And that information would be in a client hello packet. Okay, these are the documents which was being referenced when all this information was being collected. And one was the trace, one is like how net packet works, troubleshooting SSL TLS connection, troubleshooting the UTL HTTP packet, how SNI support is being supported in 12.2 with the patch, and how do we do this SRDC collection of access control list. Thank you, everybody. And that's about it for today's session. Over to you, Padma.
Thank you, Amita. All right. We are at the top of the hour where we designated to start. So in the interest of time, I have posted the recording links onto the chat, so you can access the recording as well as the slides from today. Please give us about 24 to 48 hours to post the recording. And I'd like to go over a couple of questions if possible. If anybody needs to drop, please again note that we will post the questions and answers as well as the recording to the links that I've posted. Let me just cover a couple of questions. Okay, can TDE and SSL wallets be the same wallet?
No. TDE is the encryption wallet and SSL is a wallet which is used for the certificate to have a TCPS connection. But taking from the 19C, you have something called as wallet underscore root being introduced, where you have a path selecting the same Oracle base path. In the same base path, the wallet for the SSL is being kept in a folder called TLS, and the wallet related to the TDE is being kept in the folder called TDE. Before 19C, it should not be getting confused between TDE wallet and the SSL wallet. So the TDE wallet would start with the keyword in SecretNet wallet SecretNet.ora location as encryption underscore wallet. And for the SSL wallet, it starts with the keyword called wallet underscore location.
Thank you, Amita. Next question. What is the best practice for multi-PDB environments, setting different wallets for each PDB?
Okay. Yes. So for that, we have a MOS document. Yes. For a multi-tenant environment also, you have many PDBs on a respective PDBs. You can have a feature, you can make use of feature called wallet underscore root, where in wallet underscore root for the container level, you will have a respective certificate under TLS folder. For a PDB level, if you have a 10 PDB, you open a folder, make a folder with the respective GUID of the PDB. With the GUID, you make one more folder called the TLS and keep the respective PDB TCPS certificate inside that wallet. So yes, our Oracle database supports multiple PDB certificate for TCP connection with the PDB GUID.
Thanks, Amita. When is NNE not enough and should go for TLS?
When is
NNE not enough and should go for TLS?
I'm not sure about this. I will check and answer it in the forum.
Okay, thank you, Amita. The next question, hopefully the last one. How to handle user passwords stored in wallets? Which is the wallet path?
User password is not related to today's discussion. Today was to do with the SSL certificate. That would be a complete different wallet what we would be talking about. That is called the SEPS wallet.
Thanks, Amita. I think there's a clarification. NNE, they're referring to native network encryption. When is native network encryption not enough and should go for TLS?
Okay. Native encryption, why it's not enough? Because you don't have this way of, in TCP/IP connection, you have a proper way where your user authenticates the server certificates and makes a connection, and that encryption can't be broken. There are sometimes NNE can't be completely reliable form of encryption. A middleman can attack and read the data from the NNE encryption. So the best encryption what we can go is the TLS, where we know a proper certification validation is happening and nobody can break that encryption. So it's always the best way to approach your security for your system is having a TCP connection than a NNE connection.
Thank you. We have some excellent feedback about the session. So thank you, Amita. I think that brings us to the last question for now. Again, thank you for a very informative session. We have some great feedback, and also thank you to our panelists for helping with Q&A. We hope you all found the webcast valuable. Thank you to each one of you for taking time out of your day to join us. This concludes our webcast today. Thanks, everyone.
Thank you.